Hello everyone, and welcome back to a new episode of SHENZHEN I. In the last episode, we didn't solve any new puzzles at all. We reviewed a previous solution and came up a previous puzzle and came up with a better solution. What is this? Little help prototyping? Did I skip this one? I'll create a working design. Wait. Is this the... How did I end up skipping this one? I didn't mean to skip one. Huh. Feel the connection and get ahead. I don't remember reading this one. Oh yeah, no, stop being lonely. Sure. Huh. Okay, I apparently skipped this one, so we'll go back. X and Y are inputs connected to a joystick. A and B are connected to buttons. Radio, we have a wireless controller that we can both read and write. When a data packet is received over the radio from the game console, respond with the following 3-value packet. What following 3 value? Oh, there's the next page, thank goodness. Making sure to use the most recent input values. The stupid case. Alright, so we respond with X and Y. And then depending on what A and B are, we respond with various values. Oh, so this is actually like a bit and of A and B, treating B as the most significant bit, basically. We don't really have, or bit or I should say. We don't really have that. Okay. So, on the one hand, wow, we have so many parts over here. What is all this crap? We just have parts that are not recommended now, but we can use them if we want, I guess. So like this guy actually seems like it could be kind of useful. Right? Especially at only 1 yen. We could have A and B as the inputs. And then read from this output, or flip it like that. There we go. Have A and B as go in as inputs, get as the output a number that is actually either like, you know, that'll look binary but actually be base 10. It'll be like 0 or 1 or 10 or 11. And then we could like extract a digit. Yeah, this might actually be simpler. Well, we would sort of like use this thing, which has 3 inputs. Because if we wanted to read A and B, well, actually, yeah, I bet this will be useful. I don't know, I guess we'll see. But it's a thing we could do. We could either use one of these, or we could grab one of the standard X4000s or whatever they're called. This guy. Read from A and B, and it would be a little awkward, wouldn't it, to have this guy be pushing XBus data, because we don't actually want the data every cycle. We only want it when we're asked by the wireless controller. And this guy would have no choice. It's a sort of a push model. Whereas if we use this guy, it's a pull model, right? And it's cheaper than this. So this seems like a really great deal. It seems like we really do want to use this, actually. I'm not sure whether... Yeah, and also it means the ports, like we have exactly the right chips. right? Because imagine, I guess we want it flipped. The wiring I'm thinking of is something like, it's a little bit tricky to actually draw, but which of these is XY and which is AB? Yeah, this is XY, very good. So I'm imagining something like this, and well, actually, let's not go that way. And this, so that's how it's reading X and Y, and then it's reading its X input, reading and writing, I suppose. Let's do it like this. Hey, I thought I read that there had been a patch that said you could put this down onto these guys, but apparently not. Whatever, we'll do it like this. So he's, oh, I see. No, we're not actually using up all of its values perfectly, are we? Because we need one more to be able to read from this guy. Okay. Well, that's fine. We can just graduate this into a 6000. Throw away all the wires, though. So I'm gonna have to redraw them anyway for this new do. To move the bridges, we probably still need them. I just don't know where. Okay, so something like this. We still want this guy connected here. Let's actually scooch a bit. Yeah, this should make things fit a little better, right? And I guess we gotta scooch a bit further. Like so. We can't flip this guy, can we? No. Alright. And look, this lines up perfectly with 2 X-bus inputs. Amazing. Or, well, 1 input and 1 output. Okay, having done that, let's redraw this wire to go like that. This wire goes like that. And yeah, so X and Y were connected with direct input. And this we're connected with a pole model. Okay, so that should be fine. And where are these X things going? They're just going into one of these ports, right? So just like that, nothing more complicated to it at all, right? Yeah, that sounds good. Look at this. Throw away them bridges. Who needs them? Let's go check the spec for this thing to see which of these is the high order bit and which is the low. What the hell is this part called? It's a DX300. Okay, here we go. When representing the state, the value in the ones column is P0. Okay, so this is our lowest order bit, and this is our highest. So we're going to want, I think we can do everything just on this one dude, I believe. So we're going to want, see, in this table here, A should be the lowest order, which we're representing this in the most obvious way. I think it isn't actually going to matter. We can write the code either way, but it'll be easier to remember if we make the lowest order bit in this thing be the lowest order bit in this sort of encoding. Okay, so this is, I think, our diagram. And we just need to write the code in this guy, right? Let's look at the verification just to make sure I understand. Yeah, so we're getting minus 999s to mean don't tell me what's going on, and then any other packet, which it looks like they're all -1. But we don't need to count on that. We can just, if it's not minus 999, do something. We don't even need to store that value anywhere. So we can just say, let's see, are we going to need a jump? We'll need a jump if we ever need to do a conditional again and we can't properly invert it so that this minus is harmless. I think that what I said makes very little sense. It has a clear meaning in my head, and I'm not quite sure how to express it. What I mean is, like in the way that in a couple previous puzzles we did kind of OR, right? We implemented OR as like, test a thing, and if it was true, be plus. And if it was false, then in minus mode, test the other condition. And if that one's true, arrange for that to be plus. Otherwise, stay in the minus state. And I don't think we're gonna need any other conditions at all, right? Everything else can be super, super dumb. We just have, the only test we're gonna have to do is whether the input was received. So I think we can avoid a jump. So we're just gonna say test equal Rx is on x0 with minus 999. And then the rest of our program is all going to be preceded with minuses, except for the end where we'll sleep 1, of course. So in what order are we expected to reply here? We reply with x and then y, and then the AB tuple thing. Fine, simple enough. We can just read x, that's a simple IO. Move P0 to, is that x1? And then move P1 to x1. All right, we did it. We moved x and y. We're halfway there. I mean, it was the easy half, but you know, we're still. And I think we've got a pretty solid plan for this. I gotta look up all these digit operators. DGT. How does this work? Digit get, reads it out of ACK and then stores it into ACK? That's not real useful. I was thinking that we would like store it in DAT and then multiply it by the result of a digit get or something. But I guess there's not a lot of registers to work with, are there? So clearly we need to... Oh wait! We can afford to read the input as many times as we want from this guy. He'll provide it to us as often as we ask, and the values aren't changing. So that's interesting. Can we do anything with that? We could read the input, get out a digit, possibly multiply by something, and then move it to DAT, and then read the next digit. Seems like, is there some way to do this while keeping all of the interesting work inside of ACK? I don't think so. We have to read a value. Yeah. Okay. So what we're gonna do is read the B value in its digit. Sorry, read the B value, put it in ACK. Get out, or read the whole value, put it in ACK. Get out the tens digit, which is the B's component. Double it. Store it in DAT for a moment. And then get out the ones digit and into ACK again, and then add the DAT part back in. So that seems like quite a few steps, and it makes me wonder if it would just be easier to no, right, I keep forgetting. It would perhaps be easier if we had two more simple I/O ports to, instead of doing the shenanigans of encoding it into a single digit and then extracting digits out, or a single number and extracting digits out. If we could instead just say read A, read B, and do some things based on what they are, that would be much easier. But we can't. We only have an X bus port available. So we kind of have to do this silly nonsense of reading it, checking a digit, reading it again, and gluing the results back together. Okay, so given that, I think we have our answer here. And again, this should start with a minus. We're going to move x3 into ACK. And we're going to get out the digit. How does digit work? Digit of 0, 1, and 2. Okay. So 0 gets out the 1's component. And we want the 2's component. The 2's component? What am I even talking about? We want the 10's component first, because that's the B, which is our high order bit thing. So we're going to say digit 1. And we'll add ACK, doubling it, right? We take, so if B was set, then we double the 1 and get a 2. Now we've got half of what we want our result to be. So we'll move ACK into DAT, and then, whoa! No, okay. I was thinking that we could just add what was left on the wire, but we can't. Because there's nothing. If we get back what was on the wire, it's still got 2 digits. We still need to do the job of removing that single digit. So we'll move x3 into ACK again. Digit 0 to extract the 1's digit, and then we'll just add DAT. That's the 2's digit. Now, I actually do mean the 2's digit because we're working in binary for this, the A and B component here now. We're going to add back the old digit back onto it, and just move ACK to where's our TX here? It's X1. Yeah. And in either case, whether we wrote or not, we will just sleep for 1. So this seems about right to me, right? We're testing whether we should do anything, and if not, the entire remainder of the program is skipped and we just go to the next turn. Otherwise, we just copy to make sure we're writing stuff out in the right order. X, then Y, then this nonsense. Wait a minute. Yeah, no, I was right, okay. Yeah, A is the 1's component and B is the 2's component. Fine. So we write out X and Y. Then we read this AB component combination into our accumulator. we get the tens digit, which is B. Yes. We double it, converting a 1 to a 2, basically. Having doubled it, we move it into DAT. Then we read this again and get out, this time, the ones digit. We add the twos digit, and we move the result to the output. And then we sleep for 1. Yeah, I'm pretty happy with this. Let's see how it goes. So first cycle, we got no input, so we did nothing. Great. Now we're getting an input, so we do everything. Move P0, that's X, to X1. Okay. It's hard to tell on this graph whether it's what we wanted. Oh, that's the simple input, geez. Down here, what's the expected output? Expected 63.37.0. And we don't yet have a full output, so it's not telling us whether we're right or wrong. Looks like the 63 lit up though, so maybe that means it's good. Step. And we're sending P1 to X1. Yeah, so these are lighting up, meaning we got them right. And now we're going to step. And we read from AB, which should be all zeros. And we put it into ACK, and it is all zeros. So we do our nonsense of getting out the digit. We save the result in DAT, and we read it again and got a bunch of zeros. And we're writing now a 0. Great. A and B are still not set, so this should all be trivial. Now one of them has become set, but we don't do anything this phase. Now the other one is set, and they're asking us for the data. So this is probably the most tricky input for us. I think we have it right, and I don't know. I mean, I could just run the tests and see, but I'd like to step through it so that I know what's going on, so I can confirm to myself that I understand the problem rather than just asking the machine, did I get it right? Alright, so we tested whether it's negative 99, and it's not. So we write the x and the y. We're quite confident that we're good at this. Now we read in a digit thingy, and we get 11. Good, that's what we wanted. Get out the tens digit. It was 1. Double it, we get 2. Write it to DAT. It's a 2 now. And we read it again, getting 11. Get out the ones digit, also a 1. Add them together, it's a 3. And we write it to the thing. And it's a 3. Look at that. So the other interesting test case is going to be like a 2 or a 1, where only one of them is set. So let's just confirm that we... Oops, I advanced. Well, it looks like we got it right. I meant to test it in a little more detail, but... Okay, this was a fun one. A creative... I don't know. It felt a little creative to use this guy and figure out how to take advantage of it. It looks like a very bimodal thing here, right? Everybody either did it the way we did with $4 worth of components, 4 yen, I should say. Or what is that? 6, right? Because this was a big one, not a small one, so it's 5 plus 1. Or they did it the other way with a 5. Yeah, a 5 and a 3 probably, right? Yeah, that's what that is. Is instead of using this guy, they used another chip somehow. It's not clear to me exactly what the right way to do that, if you wanted to, would be, because it's kind of hard to synchronize whether this guy should be sending, right? You might have this command and control chip send something over XBus saying, I need your value, please wake up. and then it wakes up and reads these things and ships them back. Well, does the math on them and ships them back. I guess that's how you would do it, right? You would have this guy say, please give me the value. And then this guy wakes up, and he has a much simpler time of comparing the values than this one did, because he can actually just read X and Y as many times as he wants. Doesn't have to do this nonsense of encoding them into a single number to be sent over the wire and doing that twice. And then doing the math on them in like the accurate, yeah, ugh. So that might actually save power, perhaps, to do it in that way. But maybe not, because that's, you know, a number of instructions just devoted to asking this thing to do I/O. When here we can just, as often as we want, we can just read this value, and this we don't have to pay for the power for this. At least I don't think so. I didn't see any indicator for how much power this is spending. I don't know. This one doesn't have a counter going up for how much power it's used, so. Anyway. Great! Can I get a congratulations? Thanks, man, I owe you one. You've helped make thousands of dead tired salarymen marginally happier if they actually find the console and use it to play a game before passing out. Okay, well, I think that's enough for one episode, and it felt unusually positive. Seemed like we actually did things in the right way here on the first go, which I'm reasonably happy with. I don't know, maybe I'll look at Scott Manley's and he did it like way better, but I don't think that's even possible, because maybe he wrote better code, but I don't think there is a better wiring diagram in terms of like component. Well, no, that's not true. Someone did it with just 3 somehow, right? Wait a minute. How did you do that? Component score of like less? Well, that's power usage. No one used less than 4. Yeah, so you can't do better than that. And the code that we executed was not 100% optimal. A few people found a way to do it a little bit better. But overall, I think the power was pretty good. So I'm happy with this solution. You know, would we have solved it this well if we hadn't spent some time going over what was wrong, post-morteming, if you will, some earlier solutions? Maybe, but maybe not. Anyway, I'm happy with how it worked out, and I hope you guys are too. So thanks for watching, and I will see you next time.